Visual Studio Code suddenly disappeared, so I'm installing it. It's okay, let's get started, okay? So today we are continue for the chapter 9 and 10. Chapter 9 actually is on the built-in data type. Okay, so basically it will be on the integer, character, those kind of data types. So this one we won't spend too much time. We will focus on chapter 10. Okay, so this one I think we already covered it. The short this different variable type, same as the C language. Okay, these are the primitive data types. Only thing that you need to take care of is that when you convert the data type from one type to the other, you have two ways you can do it. Is that you have an A, you can do integer using casting, you can convert it. You can also use a int function, just like Python, to convert it. Okay, and we also talk about the so-called stoi function to convert string to integer. Okay, or integer to string. You have to remember that those kind of functions we mentioned before. So those are the key idea that is a basic primitive data type you need to take care of. So this chapter, there's no much we want to cover. The maximum and minimum value, the same as C language. So we don't cover this. We don't repeat this one. Okay, so this one, I think, I'm not sure why there is a chapter like this. I actually get this one from a textbook, so I'm not sure why they have this chapter here. Okay, enum we don't cover because enum right now, not a lot of people use it. So basically, it's not really useful. So this is chapter 9. We just kind of don't spend too much time for it. Okay, let's look at the chapter 10. So chapter 10, 11, 12 will be on the compound data type. Chapter 10 is on structure and class. Class will be likely, okay? And then chapter 11 is on array. Chapter 12 is on vector. So these are the three major chapters in C++1. Then we will move on to chapter C++2, okay? So here, let's look into the structure and the classes. Okay. So first thing, let's go back to the compound data type. So let's talk about array again. Let's talk about array. So I'm going to create a new folder. Let me create a new folder. So this one, let me call it chapter 10. Chapter 10 will be long, so maybe 2 weeks. So this first week, we would cover the structure first, okay? So first one is the compound data type in C language, okay? Compound data type in C language. Compound data type in C language is different from the so-called, what's that? Java language. And it's also different from the Python language, okay? So let's look at the compound data type. So compound the CPP, okay? Okay, first we would like to cover the array. Okay, we already covered array, C language array before. And here we are going to cover the C double plus array. Okay, it's the same. Okay, actually, basically, it's the same. Let's get started. So we may have an integer array A3. Okay, so this one is different from Java type array. So this one you have A array and it declared as a 3, you will automatically declare a 3-element array. And this let's assume this array's address is AAB4. So A will be equal to AAB4. A is a reference. A itself is a reference. Okay. And A0 is the first element. A1 is this, A2. So let's do this. Let's do this. Let's do this. Let's do C out. So A is array, and I do not print out A0 or A1. I actually print out so you see A0, if I print out A is an address. This is different from Java language. Java language, if you do integer array A equals new integer array, this one is holding a pointer and pointer to a array in a heap. Okay, and this one is not. This one is not a pointer. This one is actually the address of that. This is the address of that 3-element. Is the address of that 3-element variable. Okay, so let's do this. Let's actually assign this one with 4, 5, 6. So I print now A is the address. Now let me do print now body of A. Okay. Okay. So A is the address. A0 is the first element that you see right here. Okay, so let's also print out A0. And let's run. So you see, this one, let's assume this address here. A is storing this address here, and this address actually is A0's address. So A actually store the A0's address, and body of A is A0's data, and A0 data is actually 4. And A0 data, you can also use this. Is that okay?
Yeah.
Hello?
Yeah.
So this is different from the what you know about the array. Java array, if you write this, Java array, you actually usually you write this, you write integer array A equals new integer 3. Okay, that's as soon as that. So this is Java format, okay? And this Java format is not allowed in C double plus language. I just give you an example. So in this case, when you print A, you will not print the address of that variable. It's printing the objects. So you will print out an array of integer at certain hash code address. Okay, it's not a address of that memory, and this address of memory actually is the A0's address. So when you print it, it will give you the A0's address. Okay, so this is the concept of the Java C++ array. Let's look at another one. So can you do this? Can we do this? Can we do integer? Let's do body of B equals new integer 4. Is that okay? So is that okay? If that is okay, what is the difference between this one and this one? Okay, let's actually also put it as 3. And then let's actually copy these three things as well. So here, let's do this. Let's actually don't put A, let's put B. Okay. So this is one way to create an array. This way to create array, A itself is the address of that A0's location. This one, you create a 3-element integer array using new. So when you use new, it will be created in the heap. This one, you do not use heap new, so it actually will create it in the data segment. So the location is different. The location is different. Okay. And then that's one thing. Second is that this one, when your program finish, you do not need to delete it. But this B, you will need to delete it. When you finish, you need to do delete. You need to do delete array B. Return the memory back to the return it to the heap. So you no longer occupy the memory location. So you see this one, you do body of B, it doesn't work. B0, okay, I'm sorry, body of B, it works. This body of B0, you get this. And this array actually is not cleaned because when you actually get it from heap, the heap doesn't clean it to be 0, 0, 0. No, it doesn't. This one in Java, it will clean to be all 3, 0, but here it doesn't clean to be all 3, 0. Is that okay? Hello?
Yeah.
So right here, what you need to do is that you would need to do for integer I equals 0, I less than. Can you do this? Can you do beta length? And then I increase, and then B's I equals 0. Can we do that? No, there's no such thing as a length here. Can we put a size function that is? No, there is not. So here you need to put a 3. So this one, this kind of array, you would need to define an integer b length. B length equals 3, and then before you actually put it here, so you do b length. So at the wrong time, you can declare a array of variable lengths, but they do not have eta length. They do not have what's that? Eta size, beta size, because it's not a class. Okay, this one is not a class. This one in C++ language is not a class. Later, we'll teach you a class of the array class. In chapter 11, we'll talk about array class. But right here, this one is not an array class, so it doesn't have the size. or any variable that you can use. Okay, so this one we clean up the data. Let's look at it one more time. So if we clean up the data, then it will get clean up. You get these two variables to clean up. If you do not clean up, your array initially will have garbage in there. This is different from Java. Okay, so must clean up C double plus array. If you don't, it will be garbage there. Okay, so here one way to create an array that's using the list. Okay, the other way is you use the dynamic array assignment. But here, this one, can you do this? Can you do this one? This one, can you do this? Can you do this? Can you do integer b this equals new integer 3? Let's call it C. Okay, let's call it C. Is that okay? Is that okay?
No.
Why not? Why this is not okay? And why this is okay?
Oh, because it doesn't have what is it called? I forgot what the start thing is called. Uh,
You do not understand it. You just try to answer, but you do not understand it. Yeah, it do not have a start. Yeah, but why? Why no start? It doesn't work. So what's the difference of this one, and this one? That's the key point I'm asking here. You need to understand it, and you will understand C double plus language array. How about Jessica? What's the difference between this one? Why this one doesn't work? And why this one work? This one work?
I'm not really sure.
So how to make this 19 work? So Jessica, how to make 19 work? Or how Benjamin, how to make 19 work? So my fundamental problem is actually why 19 doesn't work. So Benjamin, you said that there's a star sign. Yeah, there's no star sign, so it doesn't work. But why? What that is a star sign actually really means? That's my key problem. Then you will know C double plus language better. So Benjamin, do you know?
no.
Let me repeat one more time. Let me repeat one more time. Will you declare A3 means this is an array of 3 elements, and your A is the address of the first one. So this is associated with the memory, just like you have an integer data equals 3. So your data associated with a memory, let's assume this memory is AAB4. So at the AAB4 location, you store 3. Same thing right here. It's just like here you have multiple elements. So this one may be BB44. So at the BB44, you store 3 variables. That's as soon as 0, 0, 0. Okay, here is 456. So 456, you store 456. So BB44 store 4. BB48, you store 5. BB412, you actually store 6. But you declare this, that means that you reserve 3 elements space for A to store integers. Is that okay?
Yeah.
So this is using this kind of the array notation to declare a variable. Okay, it's reserving 3 memory space. So this integer data equals 3, you reserve 1 space for it, and you put a 3 over there. Okay, that's actually here. Now, So second one is that what does this one really means? And how it's different from this? This one you do have a new. This one don't have a new. So when you have a new, you create the data in the dynamic memory. And then you create 3 elements, okay, 3 elements. So this is B or 3 elements. But here you do have an address. Let's assume this address is BB44, okay, BB44. So B is not associated with this memory. B is a memory holder. B is a pointer. So B holding the address pointing to here. It's different from A. A is actually the memory location 3 right away. A, we call it a reference. B is a pointer. So B is a pointer. You must use pointer notation, integer body of B. Body of B is an integer. So B itself is a pointer. Pointer pointing to the dynamic memory. So you do new. So you store the memory address here. So that this one, B is a pointer. You new, whenever you new something in C language, you will return a pointer. So here, the key point is that whenever new is used, a pointer will be returned. And that returnable pointer will be assigned to B. Is that okay? Jessica, is that okay?
Yeah.
Yeah.
So now let's look at C then. C, you actually create a 3 memory location in heap. You do new, so you will return an address, but who accept the address? There is no address. There is no pointer to accept the address. Instead, you C declare as a array memory variable reference. So this is wrong type. This is wrong type of a variable. This one C is the wrong type of variable. Wrong type. You see here it said that it's wrong. New must return the pointer. You see here it has the new. Look at here. It say new function will return the pointer. You see bracket is not a pointer. C bracket itself is an array. Okay. Now one more things. So here you may have an integer d this equals so how come this one work? And why here you don't put 4? That's because D itself is a reference variable. D associated with the reference, but which reference, how long it is, we don't know. We don't know, but we actually create an array directly associated with it. So you actually directly assigning 0, 1, 2, 3, 4, with the data of 1, 2, 3, 4 to associate with it. So this one would work. But this one doesn't, because this one you do new. New, you will return the pointer, but you do not have a pointer to accept it. So C doesn't work. Okay. So these are the detail of the C double class array. You must know this first. Before we talk about this because we are going to go into the structure. If you don't know about array, you will not be able to understand structure. Okay. So far, okay?
Yeah.
Yeah.
Okay, so this one is array. Remember, these are the array. And this array, there is no cadence. There's no cadence. There's no size. There is no at the function. Okay, because this is plain array in C double plus language. There is an array class in C double plus that comes with the size. but we are not covering it right now. That will be chapter 11. Okay, we'll talk about it later. Now let's look at the structure. Okay, structure. Before we go into the C double plus structure, let's go back to the C language structure. So let's call it point. C. Okay, let's review the C language structure one more time. So C language structure. This is something you need to remember, okay? If you need to do namespace, you need to remember them. You need to do this argument vector, you have to remember. Argument counter argument vector, you need to remember, okay? Okay, now let's review the structure. So C double plus structure, you have the structure point, and then you may have integer x and integer y. Okay. So structure point. So Jessica, what is structure point?
It's kind of like a class, and then you can like make objects.
No, it's a data type. Okay. So you would actually declare a structure point P1. Is okay?
Yeah.
And P1 dot x equals 3, P1 dot y equals 4. Okay, so this whole thing is a data type. Okay. And then you do print the f. Okay, so basically you have 3 and 4. That's 2, and then it's a structure P type. Okay, and you print out 3 and 4. Now, so Benjamin, can we do this? Can we do point P2? Can we do this?
Doesn't look like it.
Can we or cannot?
No.
Why not?
Think no, it's not because we didn't put struct.
We didn't put struct, and then what happened?
So it didn't declare it properly.
So what is point?
Oh, it's not a data type.
It's not a type, yeah. So who is a data type?
Struct point.
Struct point is a data type, yeah. So you cannot use this. If you want to use a point as a type, you have to do this. You have to do type define struct point as point. Then this point two is okay, because if the point two type is defined as the struct point type. So this is a type, and originally point is not a type. So I assign the structure point type to be the point type. Is that okay?
Yeah.
So now this one is a type. So this is okay. Jessica, is that okay so far?
Yeah.
Okay, this is a C C language structure. Okay. But this one is a type. This one is a type. If I do this, if I put here as P3, P4, is that okay? Then what is P3, P4? Jessica, what is P3, P4?
Is it like, are they points?
Hmm?
Are they also points?
They are what? In C language, we call it what? What is the terminology? They are actually variables. These are the type. These are the variables, just like you declare integer A3, A4. Here, the type is structure point. And you declare P3, P4 as two structure point. Structure point is the type. What type is have the two data field type. Integer, you can declare integer A3 and A4. So this is the same thing. Here you put the A3, A4, it actually is two variable name, just like you declare A3, A4. Is that okay?
Yeah.
Must understand this, okay? I'm trying to give you the idea of what they are. So these are the basic understanding, okay? And then this P2, we can put these. So what does this mean? Benjamin, what does this mean?
You're declaring the points, right? The X and Y.
Mm-hmm.
So the X would be 10 and the Y would be 20.
Mm-hmm. So this is the same as the array. That's why initially we talk about the array. Array, you actually have A, you will have the location 0, 1, 2. You will assign 4, 5, 6 to it using this. So first memory go to the first memory, second memory go to the second memory, third memory go to the third memory. Is that okay?
Yeah.
Same thing right here. Your C language, you have point type. Point type has two memory location, X and Y. So when you do 10 and 20 with this one go to here, this one go to here. Okay? And Benjamin, it is a P2 a pointer or not?
No.
No, it is not. Okay,
Yeah.
it is not. Must understand it. Okay, it is not. It actually is a variable name with two data location. Okay. Okay, that's something we need to learn. This is the C language structure. Now let's look at the C double plus structure. So C double plus structure, we'll use a pointer as well. So let's call it point.cpp. Okay. Point.cpp. So let's do include. Okay. So we actually would like to work on a structure for what? For C double plus. So we do structure point Here, remember you need to have a semicolon because it's a data type. Okay, it is a data type. So right here you do have an integer x, integer y. So this one you declare a type called pointer type, and then you have xy. Okay, this different from the C language is that C language the type is structure point. And then C double plus type. C double plus type is the point. So it's the difference. So right here, if you do this, if you do pointer P1, P2, that's okay. That's okay. Okay is C double plus, but not okay in C. C, you have to do struct points. P1. You cannot do point. Otherwise, you have to do type define. Is okay?
Yeah.
Okay. But how to understand this structure point in C double plus language? C double plus language structure is mini class. What do I mean by mini class? Mini class means that if you write a class, it's class pointer class, right? And then right here you do integer x, integer y, and then you have a constructor p, integer x, integer y, whatever, blah blah blah. Is that okay? Hello?
Yeah.
Is that okay? So C double plus structure is a mini class. It's a mini class, so C double plus also have a constructor. So we will put a constructor here. And then right here you would have you would put this, you would do integer a, integer b, and then you will assign x with a and y with b. So this one is a basic structure definition. It looks like a class. Everything look like a class. Okay, look like a class. So here you see right now you actually have the constructor of these. There's no default constructor because there's no argument constructor. So these two doesn't work anymore. So here you can put a constructor for it. So you can do pointer nothing, that is x equals 0, y equals 0. Then these two still okay. Otherwise, you have to do point P3 C4. This one will call the constructor. Is that okay so far?
Yeah.
This one will call the constructor. It is not like this. It's not like this. It's not pointer P3 equals new pointer 3, 4. No, it's not. Okay. This is Java format. Okay, this one is Java format. Okay, now we are not doing Java. I just done this for your comparison. No, this is not, this actually is like that. It is calling the constructor. So if you do not have the parentheses, you will call the default constructor. Default constructor is who? This one is the default constructor. Okay, so you can have multiple constructor. Okay. So we say it's a mini class because everything is public. So it actually is a mini class means that if you use structure, everything is public. There's no such thing as private or protected. Everything will be public. Okay, everything will be public. That's what mini class means. Second, mini class has no inheritance. So there is no parent class, child class, no, those kinds of things. You cannot extend the class, no, nothing like that. You can only have the class itself. So in a way, it is in the middle of the class and C language class data. Okay, C language is up to here only, but you do have a constructor. You can put function in it as well. You can also put a function in there as well. But there is no public or private. There's no inheritance. That's the C double plus structure is. Is that okay so far?
Yeah.
So in a way, you can also have the integer get x. Okay, because it's actually it's a mini class. So you actually define the getter and setter is fine. They allow you to do that. Okay. Is that okay so far?
Yeah.
Next one. You can also define a toString function for it. Okay. So this one, because you want to define a toString function, so you must include a string class. Okay. And then this one you will return what? you will define a two-string function. And this two-string function will call the two-string function from std domain. If you do not put this std : you do recursive call, then that's wrong. Okay, then that's wrong. Is okay? So let's do cout p3. Let me try p3 first, okay? It is not okay. So let's try p3 dot p3. There is a way that you do not need a two string, okay? I'll talk about it later, but not right now. There's a way that you can do it. These are previous wrongs error, okay, but it's okay. Okay, so this one print out 3 and 4. Any questions so far?
No.
So this one is a mini class. A mini class to have data field, to have constructor, to have the getter, setter, two-string function, just like your class. Only thing that you need to take care of is here you do have a semicolon because it's the data type. Okay, it's different from Java language. Java language doesn't have this in the class. Here, it looks like a class, but you do have a semicolon. And C++ class also has semicolon, so that's something you need to remember, okay? Other than that, it's a little bit mix of the C language structure and also C++ the class, okay? Okay, this one, the basic one. Let's go through the chapter 10, okay? There are a few features we need to discuss, more detailed one. So this one, we are going to talk about the structured data type. Okay, so it's structure. Second half will be on class. So today we are more focused on this structure type. Okay, structure type itself can do for 1 week. Okay, so structure type you have array, structure, and class. So today we are focused on struct. Okay, array we just mentioned it. Okay. Okay, one more thing. One more thing is like you can use a constructor to run it. Okay, you can use a constructor to run it. You can also use a no argument one. You call this a no argument constructor. Okay, there's no problem. And then you can also do this. You can also do pointer p4 equals curly brace 5 and 2. Okay, that's also okay. Okay, another one, you can also use pointer p5, and then you curly brace 10 and 20. That also work. That also work. Okay. You do it in this way, in this way, in this way, in this way. They all work. Okay. That's when you initialize your value. Any questions so far?
Oh, what's the point of a constructor? You can just do like line 37.
You can use the 937, so you bypass the constructor, yeah. You just directly assign a value to it. But sometimes you may build an object with new value. Your constructor may do more than just assign a value. Here, you may actually print out something, you may do something else. You may print out something. You may have a counter. Your constructor may have integer counter C. And then here you actually do C increase. You know what I'm saying?
Yeah.
Hello? So using the constructor and directly assign value is totally different things. We just say that they both okay to do it. But sometimes you declare the variable, but you do not know the value. You do not know the value. So you need to use the no argument constructor, and then later you assign value to it. So later you use a set X or set Y to it, right? So either way it works. Nobody said that it doesn't work, but C++ allow more way to do things. A little bit too flexible, okay? A little bit too flexible, so you need to remember more things in C++, okay? So basically, in C++ language, you actually put something in the bracket. It just directly assign value one by one, okay? Okay, there is another special way to do it. We'll cover it soon, okay? We'll cover it soon. Right now, it's not everything that you can do here, okay? We will actually show you later. There is yet another way to do it. So compare class and structure. Class has a template of object. Structure is a template of record, okay? Class is a member of a class. Structure is a member of structure. So here you do have data field member function. Here you also have a data field member function. But remember, this one may have private and public. But this one only public. This one you may have data field from parent, also from parents. And this one structure no parents. So no parents available type. Member function, you can have a member function. You also have a member function. Is that okay so far? Okay.
Yeah.
And you may also have another type called array. An array, no data structure template. There's no constructor for array. Array directly assign value to it. Right. So class and structure has constructor. Array no constructor. So array you directly assign a value using this. But if you assign value directly to structure using these or to class using these, still okay. Still okay. Is that okay so far?
Yeah.
Okay, these are the something you need to remember, okay? Comparison. So right here, the type, variable type is this one. You can declare with this and then followed by the object value. So you can put a P3, P4 here, that actually is equal. Okay, still equal, but type is this type name. It's no longer structure type, okay? So here is structure type name. This type name can be used over here, okay? It's no longer structure type name as the whole type name. So C double plus, your type name right here, you directly using type name. C is structure name, you have to use a structure name, or you redefine the structure name to type name. Okay? And C double plus, C language, here you put the object name right here. This is type, this is object, this is type, this is object. So right here the same, you can also put the object name over there, okay? So type name, object name, you have to be very clear or understand them. Any questions so far?
Nope.
So in a way, you got this structure and you have a constructor. So basically, it's quite different from C language. So C language, remember the function every time you have to do what? Every time you have to do using this putting the variable of the pointer to the structure to modify the structure. You might use alias to modify it, right? No, right now here, you do not need that. Okay, you do not need that. You do not need to use the pointer type to help modify a object. Okay, no longer. Let's look at one example. Let's assume here you actually have this one. You do have the structure, point structure right here, okay? And then you do have these different things. Now, let me actually define a function right up to here. So here let's do bold, okay? Change. You have a pointer, p, okay, and then integer x integer 1, okay. So this pointer p, you have integer x, p integer y, so p dot x equals x, p dot y equals 1, okay. Now here we do have p5 equal this, right? And then we do change p5 1 and 2. And then we print out the p5 object again. Okay. And then what happened is this p5 doesn't change. Why? Why is p, you put p5 over here and assign 1 and 2 here, but this p5 doesn't change. Why? So Benjamin, you know why?
No, not sure. Thinking about it.
How about Jessica? Do you know what?
Is it like because it's a copy and then after you call the thing,
It actually copy and then not changing. So right here, what happened is like when you call change p5 with 1, 2. So originally your main function, there is a p5 variable. P5 do have x and y. It's 10 and 20, right? And then you call the change function. So change function do have a p object. P variable. So this is P variable. You also have the S and Y. So you copy your 10 to here. You copy your 20 to here. Then this X got changed to 1. This one got changed to 2. So P change, P5 doesn't change. Is that okay? Is that okay so far?
Yeah.
So it's a copy by value, 4 by value, and it's a value of 2 data field. It's still 2 available, but it actually have the XY in there. You copy the 2 value to there. So now if I want to change the P's value, P5's value, what should I do? What should I change to the change function? Jessica, how can I change this change function to make it work? If I want to change the value of the P5.
Is it like use pointers for X and Y?
How can I change?
Add a asterisk
At where?
in the constructor.
Constructor? Here?
Oh wait, no, not the constructor. Like in the change,
Tell me where I should need to change. So
like
X
before the X.
here?
Yeah,
Put what? Put star?
yeah.
No, this doesn't work. Put star, you make the P as a pointer, X as a pointer. X is not a pointer, X is the value.
Oh wait, then the point
Where?
before the P.
Before P, you put a pointer?
I think so.
No. Yes or no? Yes or no? Okay. You put a pointer, then you need to use this. And then right here, this one, you no longer use this one. You have to use the address. No, but this is okay, but that's not the best answer. That's not the best answer you want to have. So to make it work, not making it as a pointer, make it as an alias. This one will make it work. Make it an in-out variable. So remember this one?
Yeah,
What does this mean?
like alias.
Yeah. So what an alias means? P will share the variable with P5. So whatever you do to P, you do to P5. Okay? Is that okay?
Yeah,
Okay, these are the idea that you need to remember, okay? You want to study C double plus, you have to remember all these. Okay, let's continue. Next one, we are going to look at the initialization of the record now. Now, when you do assign of these, this is the first way you do it. You don't need to call the constructor, but if you do this kind of listing, you assign the value one by one, one by one. So this is the first way you can initialize structure, no problem. Okay, don't call the constructor, or you do not have a constructor, that actually is fine. Just assign the value by listing, that's fine. Second one, you may use this one, the structure.name to be assigned with the value. This is the second way to do it. Okay, this one is like P1.x equals 3. Okay, so that actually is fine. Is that okay so far? Is that okay so far? That's the second way we can do it.
Yeah.
But there are other ways as well. Third way is that you may do out of order assignment. Let's try out of order assignment. So out of order assignment means you have this one. Let's do point P 6. Let me see. There's a X and Y. So here you do have G equals dot X dot Y in the middle. You use a semicolon here. In the middle, you use a semicolon. This should be fine. Okay, this should be fine. Let me see. This doesn't work. Okay, this one doesn't work. Okay, this one doesn't work. Let me try the other way. This one doesn't work. Okay, anyway, this one, some compiler works, some compiler doesn't work. So here it doesn't work. Okay, I'm not really sure this one. Okay, so let me commit it out. Okay, number 6, commit it out. It doesn't work this way. So this is way 3 may not work. Okay, next one, let's look at another one, way 4. Way 4, you have using the constructor. Okay, no problem. But constructor, they do have the initialization list. You can write the initialization list. Okay, so let's look at this one. This one, you actually write in this way, but you can write in a different way. You can write this. You can write pointer and then let's see. It should be column. So column X, put a 0 in there, Y, put a 0 in there, and do nothing. Okay, so here you are supposed to put more function in there, but right here we do not have any function in there. But this one is the initialization value of this. This one is the initial value of this. Is okay? So this one, we can also rewrite it as pointer, integer A, integer B, and then initial value X using A, Y using B is initial value. And function, we do not have any function. Okay, this is the same. You write in this way or this way, these two are the same. This way or this way, the two are the same. Okay? Any question?
No.
Okay, so these are the initial lists. So here you can put the initial list. It's different from Java. Java don't have this initialization list. Okay, you can put the initialization list over there. Okay, that's the initialization list. So you can write in the traditional way, that is, you can put it in this way, you can put it in this way. Okay. This way you have the 0, 0, 0. This is default value. Okay. Default value. Default value. If you don't have D value, if you have no just one value, then that will be assigned to D. If you have two value, it will be assigned to D and M. Okay, this is called default value. Is that okay? Just like Python have default value. If you do not assign value to it, you will get zeros. That's called default value. Copy constructor. Copy constructor. What is copy constructor? Copy constructor means you have point P7 and you put a P5 in there. Okay. This is one way you do it. The other way to do it is point P8 equals P5. Okay, it's called copy constructor. Okay, so copy constructor, the value of the P5 will be assigned to P7 in this way. So basically, your P5, you have 1 and 2. Your P7, you copy the 1 to here, 2 to here. Okay? Is that okay?
Yeah.
So this is also copy constructor. But if we do this, if we assign after it and then we say P7's X equals 100, P7's Y equals 200, and we print P7 and we also print P5. Then P7 is changed, but P5 is not changed. Before P7, we do copy. But P5 will not be changed because the copy constructor, you will create a new object with new value. Okay, so this is P7. This is P5. This is P7. This is P5. P8. Okay. So P7 got changed, but P5 didn't. So this copy constructor is not alias. This is not alias. If you want to share the value, say let's do P9 alias of P9 equals P5. Then this P9 is an alias. It is an alias, so P9 that x equals 1000, P9 that y equals 1000. Then let's print out P5 and P9. Then both P5 and P9 will be changed because P9 and P5 now are two alias variable. They share the same memory location. While P8, P7, they do not share the object. They just copy the value over. Is that okay?
Yeah.
Okay, so this kind of alias and memory, you have to really understand it. What does the copy constructor mean? Copy constructor means that your content will directly clone one copy to my content. But after that, you is you, me is me. I update mine, you update yours. We don't share the same value anymore. This is copy constructor. But the alias means like two object, we are alias, it means that P5 is mentioning about this object. P9 also the same object. P9 update, P5 also got updated. Okay, that's the so-called alias. So here this change function, you need to use alias. You need to use alias. It's not using pointer. Okay, pointer, you can use pointer to work like a alias, but not every time. Okay, not every time. Okay, so that's that. Next one, aggregate function. Aggregate function is that you do apply a function, several function together to it, like a whole. Okay, that's called alias. So there is arithmetic function. You can do this structure. There's assignment. You do have the copy constructor. Okay. And then function returning value, when you return, is also a copy constructor. Okay. Is that okay so far?
Yeah.
When you call or return, it's not just one variable got passed over. It's actually the whole thing got passed over. Okay. So these animals to another variable. So everything inside this animal will be copied to the another animal. Okay. It's a copy constructor. Return value the same thing. Okay. Return value is also the same thing. Let's try the return value there. So P9, P5 are 1000, 1000, right? And then I create a new point, and then that new point would assign 10, 10 after the calling. Okay, let's do before the calling. Okay. Okay, so basically you copy the P5's content to P10. So P10 after the call, you got this, but P10 can be updated. But P5 still remains 10,000, 1000. Is that okay so far?
Yeah.
But if I want to allow this P10 to update SY to the P5, what should I do? I need to return the left-hand side value. And then do this one. And this one also need to be alias. Then P5 got changed. Let's see this one. Let's look at this one. This one you will then you will update your P5 as well. Let me see. Let me save. This P5 got updated. Oh, this one is a new variable. You need to do a alias. You cannot copy it. Okay. Then the P5 also got updated by doing this. Okay. So this one and the one that I use, let me copy it one more time. It means totally different things, okay? This one and this one mean totally different thing. The top one never change the value. It just copy, copy, copy. The bottom one, this one just copy, copy, copy. Copy, copy, copy means that here the P5 copy to here, P copy to G, G copy back to P10. It's copy, 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 okay? This one is different. This one is alias, alias, alias. P is the alias of P5. P5, G is the alias of P, and then P10 is the alias of it. Okay. So this either way you have to figure out you want to share the alias or you want to share the value. Is that okay so far?
Yeah.
Okay. This part portion, I'm just going into the detail of the parameter and the return value for using the structure. Okay, right here, as you can see, I'm trying to give you the idea of what is the passing a variable to the function using normal variable or passing the value to the function using alias. Okay, that's something we want to know. Hierarchical structure means that can you put a structure inside another structure? Yes, because the structure itself is a data type. So you can have a structure inside a structure. That actually is fine. Okay. So basically, you may have a structure that actually is data. There may be a structure is a statistic, but in the statistics, there is a date. Because you may have a statistic, and that statistic has a date. Okay, and then you may have a machine record, and the machine record has a statistic type that actually is this structure. This is this. Is that okay so far? So structure inside a structure inside a structure is allowed. Okay? Any questions so far?
No.
This we don't go into the detail for the explanation, okay? I'm just giving you the example here, okay? And structure also may have functions just like your get x, get y, set x, set y, okay? Pointer, we'll talk about pointer later, okay? Okay, let's also use the pointer. Let's look at the pointer. So pointer, wait, new point. Oh, this new point, I need to commit it up. So here, let's look at the new structure pointer. You can have a structure, you can have using new to create a object and assign the object to the pointer. That actually is okay. Okay, that actually is okay. So let's try this one now. So far we have been dealing with the structure. So now let's do pointer body of the P to the PTR. Okay, a pointer to point. Okay, pointer to pointer, and then you do new point 10. So new point 10 again. This one create a object in the heap. And the age has been returned to the pointer. So P pointer pointing to the record. Okay. So when you print out the data, you have to do this. You have to do cout P pointers, P pointer. Okay. Any questions so far?
No.
This one is using the new constructor, okay? Using the new constructor, but when you will return the pointer, you need to use the pointer structure. Now let's try another one. Let's actually do new array or structure. So sometimes you knew, instead of new one, you knew multiple of them. So let's assume you have, here you do have student, okay? Then here you do create a array of 3 students. Each one you need to initialize with the value. You do this. Okay. Now let's try this, okay? Let's try this in our, okay, let's try this. This one means, this one is very important, okay? This one very important. This one actually combine everything we learned today. So this one means that you have a pointer, body of the point distance equals new pointer of street. Okay, and your p list 0 will be equal to 1 to p list 1 will be equal 3 4 p list 2 will be equal to 5 6 4 and p from p list c of p 2 2 2. This is not allowed. This is not allowed. I'm sorry. You have to do integer I equal 0, I less than 3, I increase. Okay, this is a new 3 pointer, and these 3 pointer are, each one is a pointer point type. So they do have a XY in there. And the address of this one being assigned to the P list. So P list is pointing to this array. And then 0, you assign 1 to there, 3, 4, you assign to here, 5, 6, you assign to here. Then each one of them, you actually print them out. Is that okay so far?
Yeah.
Let's run it, okay? This one is the last thing we would like to talk today. Array of pointer to point, okay? Point is a structure. Okay? It works. Okay, union we do not cover today. Union we will bypass, okay, easy. Next time we'll talk about class. Maybe next time we shortly talk about union and then we'll go into the class, okay? For the next time. Any questions so far?
No.
No.
So next time we'll talk about class, and then one more week we'll talk about array class. Array class is not array, okay? It's actually more complicated because this array class would have functions. So it's different from the array we talk about here, okay? It's a class of array. So it actually is called std array. And this one it is different. It actually need to include array. Right here, the array we talk about doesn't need to include array. Here, the chapter 11's array would need to include array. Okay, that's a total difference. And then chapter 12 will be on vector. Vector is a little bit like array list. Okay. So here, chapter 9 is array, is the original primitive array. 11 is array class. And then 12 is array list that we call it vector. These three kind of array are totally different. They are all different. Okay, they are all different. But we are up to here today. Okay. Any questions so far?
No.
Nope.
Okay, that's it for the day. Thank you. Bye bye.
Bye bye.
Thank you. Bye bye.